What is the purpose of linear equations? Applications of linear equations are vast. For us to tackle realized problems using algebra, we convert the given situations into mathematical statements in such a way so that it clearly illustrates the relationship between the unknowns and the information provided.
Hello guys, so right now I inviting all of you guys to the monthly meeting to discuss what our company, which is Clear Face company, had achieved this month. So as we all know, we sell a lot of products, but right now I want to do the discussion on these three products, which is product X, Fresh Glow, product Y, Deep Clean, and also product Z, which is Hydra Boost. And most of all of these products are facial cleansing that we sold. So good you guys, our company this month has achieved a very high achievement, which is our sale for these three products has booming. Yeah. So right now the problem is we need to recalculate the value of raw material needed, labor hours, and also the machine hours needed in order to produce all of these products.
So now we lack of three types of resources, which is raw material, labor hours, and machine hours. So the raw material we need is 100 liters of aloe vera gel and 120 worker hours. So about the machine hours, we need 90 hours on the Clinomatic -1 2000. Yeah.
So based on the resource, we get three requirements per product. So for the first one is Fresh Glow X, have 2 liters of aloe vera gel, 3 labor hours, and 1 Clinomatic hour per unit. So for the second one, Deep Clean is Y, have 1 liter of aloe vera gels, 1 labor hours, 2 Clinomatic hour per unit. So for the last one, Hydra Boost is Z, have 3 liters of aloe vera gels, 2 labor hours, and 1 Clinomatic hour per unit.
Okay guys, so from the requirement that we have discussed before this, so this is the equation that I have produced, which is from the raw material, the labor hour, and machine hour, to get how many product that we can produce for product X, product Y, and product Z. So right now our mission is to calculate this equation using matrix method.
So now we are going to learn how to using Gauss eliminations to solve the linear equations. So by this we are going to understanding the concept of Gauss eliminations and able to use to solve the linear equations. This is the example question, which is the equations we need to be solved. The main step using Gauss eliminations is we need to write the argumental matrix first, and we need to do matrix row operations to make sure the matrix in row echelon form. After that we can make to substitution. So for the step 1, we just turn the linear equations to the matrix forms like this. So step 2, we need to make sure the matrix form is in the echelon form. So in echelon forms, this number in this place must be 0 and must be 1. So this is the process. For the first one, we need to make sure we get a new row 2 by row 1 multiply 3 minus row 2 multiply 2. So we get the new row 2, which is 0, 1, 5, and 60. So for the new row 3, we need to row 3 multiply by 2 and minus row 1. So we get a new row 3, which is 0, 3, negative 1, and 18. So come to this, there's only one number in row 3 is not equal to 0, so we need to get a new row 3 again. So row 3 minus 3 row 2, we get a new row 3, which is 0, 0, negative 16, and negative 1. So after that, there is only A11 and A33 is not equal to 1, so we need to row 1 divide by 2 and row 3 divide by negative 16 to ensure them is equal to 1. So with this, our matrix form is already in echelon form. So we just turn back the matrix form to linear equations and apply substitutions. By these equations, we know we get the x3 is equal to 6.25. So we just substitute in the second equation, we get x2 is equal to 28.75, and also we get x1 is equal to 26.25. So this is the answer. Thank you.
Okay, next we're gonna move to Gauss elimination method.
So this is the question. 2x plus y plus 2z equals to 100, 2x plus y plus 2z equals to 120, and x plus 2y plus z equals to 90. Okay, to answer this question in Gauss-Jordan elimination method, we're gonna change the question into a matrix form first. And we're gonna change the matrix to identity matrix, where there will become value at here, here, and here, while the rest becomes 0. And you can see, this will become the x, y, and z. So, we know that this matrix have 3 row and 3 column, right? So for the first row, it is 2, 1, 2, and 100. So we're gonna make sure that row 1 and column 1 will become 1, where we're gonna divide row 1 into 2. So this will become the product. And make sure to remember that 100 is also must divided by the 2. So become 50. And next, we're gonna change the column 1 for row 2 and row 3 to become 0. So we make sure that this and this value must become 0 at the end. So we're gonna change it, but just play with the row 1. Don't use row 3 or row 2, because the initial one is using row 1. So like you can see here, 3 minus 3 row 1, where 3 minus 3 will become 0, and this will also will do the same thing, where 1 minus 3 row 1, and this will become the product. And make sure this 120 also must minus with 3 row 1, where 3 times 50, which equals to 150, and it will form negative 30. Same with row 3 minus row 1, to make sure this one will become 0 at the end. Okay, so the rest is just the same, but we're gonna do it separately. Like here, you know that negative 0.5, we're gonna make sure that this value will become 1. So we're gonna divide it by negative 0.5, and the rest is just the same. Row 1 minus 0.5 row 2. Like you can see here, we play with just row 2 and not row 1 or row 3, because we don't want to mess up the row 2 where the form will become 1. So at the end, this will become 0. And lastly, same with row 3, where row 3 divided by negative 8 will become 1. And do the same thing to make sure last it will become 0. And the answer will become x is 26.25, 28.75, and 6.25. Where I say before, it is x, this is y, and this is z. So this is the answer. That's all from me. Thank you.
Hello everyone, today I will explain about inverse matrix method in the matrix algebra. So during this method, students will be able to solve system of linear equation using the inverse matrix method and understand the condition of existence of an inverse and interpret the solution geometrically and algebraically. So the equation we need to solve is listed here, 2x1 plus x2 plus 3x3 equals to 100, and the second equation will be 3x1 plus x2 plus 2x3 equals to 120, and x1 plus 2x2 plus x3 equals to 90. So step 1, we need to identify matrix A as the coefficient of x1, x2, x3, and here is the picture of A, and the matrix B as the constant, 100, 120, and 90, and the X matrix as the value of x1, x2, and x3. So step 2, we need to make a transpose matrix A. First, we need to copy down the matrix A, 2, 3, 1, 1, 1, 2, and 3, 2, 1. And second step, we need to copy the first 2 columns, and then we copy the first 2 rows, and as the picture, the third picture here. And the last one, we need to delete the first row and the first column, so we can get a adjoint matrix by calculating the determinant of each coefficient. And step 3, we need to find the determinant of the matrix A by multiplying the first row of the matrix A and the first column of the adjoint matrix. The step 4, we need to get the inverse matrix of A. How you get the inverse matrix of A, we need to divide the adjoint matrix with the determinant. And here is the picture of how to do it. 1 over 8 times the adjoint matrix. Step 5, we need to multiply. We need to get the matrix A by multiplying inverse matrix A with matrix B, and we can get the final answer, which is x1 equals to 105 over 4, and x2 equals to 115 over 4, and x3 equals to 25 over 4.
Hello everyone, so today I want to explain about Cronus method. Okay, so this is the Cronus rule that we will implement in order to use the method. So this is the equation, and then we will change it to the matrix equation, which is in the form of A, B, C. Okay, you can see this. And then the first one, we need to find the determinant value of the matrix A. Okay, so basically we need to find the determinant for 3 times 3 matrix. Okay, so basically you need to take the first row. okay, in the first element, for example, and then we will eliminate the first row and the first column, and we will take the remaining matrix, which is 2 times 2 matrix. We will do the same for the 1 and 3. Okay, and you need to take note on the sign conversion, is very important. And then we will find the value of determinant for 2 times 2 matrix, which is we will use the value of the equation AD minus BC. And then in this case, we will do 1 multiplied by 1 and then minus by 2 multiplied by 2, which is we will get the value of determinant for the matrix, which is -3. Okay, so we do the same with the other matrix, and at the end of the calculation, we'll get the value of determinant, which is 8. Okay, for the x, we need to change the value of the first column with the value of matrix C. This is because we need to change the value of the coefficient x with the matrix C. Okay, and then we find the determinant of the x matrix, and we'll get the value 210. And then to find the value of x, we just divide the value of x with the determinant, and we will get 26.25. And then we need to find ay, which is we need to come up with the matrix first. Basically, we need to change the second column with the matrix C, and then we do the determinant calculation, and at the end of the day, ay will equal to 230. And to find the value of y, we will get 28.75. Okay, for dz, we need to come up with the matrix AZ first, and then we just change the third column with the matrix C. We find the determinant value, and then we will get AZ equal to 50. Okay, so to find the value of Z, basically 50 over 8, and we will get 6.25. So this is the result, and you can see that for all of the methods, the value is basically the same.
Alternative method to solve linear equation is graph method. Graph method is when we substitute any value into one variable until we get solution for all variables using application like Desmos. Second method is iterative methods like Jacobi methods. To find the solution, we need to perform repeated calculation, and this method is suitable for a large system since it requires less memory.
Moving on to the application of system of linear equation in chemical engineering field. We can use it to balance chemical equations by using Gauss-Jordan elimination method and Gauss elimination method. For example, here's a chemical equation that is not balanced. Then we will assign unknown coefficients such as W, S, Y, Z to each chemical species. Then 3 simultaneous linear equations corresponding to each of these elements will be produced. For example, carbon, hydrogen, and oxygen. Then we will turn those linear equations in matrix form. Then we will use Gauss elimination method to turn those matrices into echelon row form. Then we will turn the echelon row form by using Gauss-Jordan elimination method into reduced row echelon form. Then we will obtain that the solution of the system of linear equation is W equals to 1 over 2Z, X equals to Z, and Y equals to 1 over 2Z. Where Z is a free variable, particular solution is then can obtain by assigning values to Z. For instance, Z is equals to 2, then we obtain that W is equals to 1, X is equals to 2, and Y is equals to 1. Then we replace these values as the coefficient to our original equation. Then our chemical equation that is not balanced will be balanced.
Okay, now we'll be talking about real-life application of mechanical engineering field on the matrix algebra. So here we have a question that involves a force of 100 Newton and a horizontal and a member of AB, which is horizontal, which is 3 meters long, and also a member of AC that is inclined 45 angle and a length of 80 meters. And so we need to find the point A and point B. So we establish the equilibrium equations, which the sum of force in x direction, y direction, and the moment about point A is equals to 0. And we substitute the equation inside that we get these 3 equations listed here, 1, 2, 3, and the matrix form is A multiplied by R equal to F, and where matrix A is represented by this matrix and R matrix represented by this matrix, and F matrix is represented by this. And the first thing we need to do is calculate the determinant, and after we get the determinant, we find the inverse of A. And before we find the inverse of A, we need to find the cofactor matrix, and taking the transpose of the cofactor matrix to become an adjoint A matrix. So now we can compute the inverse of A, which is 1 over determinant of A multiplied by adjacent A adjoint A. And now we can solve R by plugging inside the equation. So the final answer we get is 0 Newton for RAX, 150 Newton for RAY, and 50 Newton for RBY. That's all from me.